In this video, I will show you how to perform struct variation analysis in linear module of the FuSViz. Linear module of the FuSViz is built on basis of the embeddable interactive genome visualization JavaScript library rgv.js. After user imports the genome reference annotation resources and the SV from the DNA-seq and RNA-seq data, we switch to the linear modules. In linear modules, SV can be loaded in different types of the genomics tracks. Currently, FuSViz accepted 4 types of the tracks: bed pie, segment, bed and bed graph format. First, we loaded SV in the bed pie format. We click the load and fresh DNA SV tracks in the bed pile. Intron chromosome SV are denoted as curves that linked breakpoint site. After click a curve, a window pop-ups with the future description of the selected SV, the genomics start-end of this SV, and the sample names. The scored values indicate the number of samples has such SV, and the SV type. Next, we loaded the SV in the segment format. We press the load and fresh DNA SV tracks in seq. 2 types SV duplication and deletion represented copy number abbreviation are displayed, in which duplication and deletions they are colored by the red and the blue bars respectively. A window pop up with a feature description of the click segment. It shows the chromosome and start coordinate and end coordinate for this segment, and also the sample names. The value 1 indicated the duplications. -1 indicated the deletions. Here, the layout of the segment tracks are shown as the expanded model. The user can adjust the size of the tracks through the click the set tracks light. We can change to 150. User can also select the squish option in the display mode. It will show the SV events in all the samples. We will see this is chromosome 21. There is the deletions between ERG and TMPRSS2. Then we loaded the SV in the bed and the bed graph format. Press the load fresh DNA breakpoint. The SV breakpoint tracks in the bed colored by the green and the bed graph colored by blue are loaded together. In the bed format tracks, a window pop up after click a breakpoint. It denoted the sample name and read support numbers and SV type and the chromosome and genomics coordinate of start and end for the other breakpoint. And the bed graph tracks display the frequency of the recurrent breakpoint across the samples. After click a peak, the frequency numbers of the breakpoint are shown in a pop-up windows. The bed and bed graph tracks is used for an identification of the breakpoint hotspot regions. Here we look at an example and identify recurrent duplication involved in an upstream enhancer for AR genes. First, we input the AR genes in the search box. If you look at the bed pile track, there is a high density regions in the upstream regions of the AR genes that indicated struct variation events is enriched around these regions. If you look at the segment tracks for duplication and deletions, you will find there is the duplication events which is overrepresented compared to deletions. We can zoom in. Then we click the show coordinate of this RGV session windows. Then we copy the genomics coordinate of this RGV session windows. Then we paste. We click the load and refresh DNA SV tracks in seq again. Then the duplication and deletions, which has a overlapping with selected windows, will show in the tracks. Here we change the track light to 150. Then we show the display model and the scratch. Next, we can load the enhancer bed file. A highly recurrent duplication of an upstream enhancer GSX1066900 is enriched for the AR genes in this sample cohort.